Most students look at the function and freeze. They see curves, lines, weird shapes, and think it's impossible to understand. But what if I told you every function you've ever met comes from just a small family of parent graphs? Welcome to the ultimate guide to functions and transformations, the video that will finally make everything click. Today I'm going to show you the secret blueprint behind all graphs, the 8 parent functions, the superheroes of algebra. Once you recognize these shapes, you can transform anything. You learn how a simple move inside the function shifts an entire graph, how one negative sign flips everything upside down, how stretching just one number can turn a cute little function into a monster, and then the master key, the ultimate transformation formula. With this one formula, you can take any function and sculpt it into any shape you want. We'll build function machines. We'll break the domain traps that confuse millions of students. And you will finally understand the composition, not as messy algebra, but as a pure logic. And finally, we'll unlock inverses, exponential and logarithmic reflections, how to reverse any function, and how to prove with confidence that your inverse is correct. By the end of this lesson, you won't just memorize transformation. You'll see them, you'll feel them, and for the first time, you have complete control over the graph. So let's begin. This is Function and Transformation Mastery. Let's transform the way you think about math forever. Hello everybody, hope you're doing well. My name is Mahmoud Kiasari and welcome to the next subject, which is related to advanced algebra. So at this subject we are trying to talk about the function, most specifically how we can draw them, talk a little bit about the reverse function and how we can combine the functions together. So without further ado, let's just get it started. So at this point we are trying to talk about the ultimate guide to the functions and transformations. By the way, transformations means that how we can move the graph left to right, top to bottom, or maybe stretch them or some kind of expand them. And at the end of this module, I expect you guys to some kind of look at any functions and know exactly what does this graph look like. So let's get started. So the very first thing that we have to be familiar with is that we do have different kind of parent functions. It means that those functions are going to be considered as the main or original one, and other functions are going to be derived out of them. So the very first some kind of functions that will be considered as the main one are the 3 functions. The f of x, by the way, f of x is another form that we are telling the function itself. F is the abbreviation for, means the first letter for the function itself. So when we do have f parentheses e, means that I do have a function is going to receive my x as an input like the machine, and the output would be something else. So at this point, let's talk about it. By the way, f of x again is going to be considered as y. If you guys remember from previous chapters, we had y is equals mx plus b, which was about the linear equation. So y is just f of x itself. So as we all know, f of x is equals to x is the very first one, or we call it as a linear function. What does that mean? It means that this function is going to have the input, whatever your input is, x is going to be considered as input, and after that the output is going to be as the same as the input itself. So a couple of examples means that if you did give this guy 0, the output would be 0. If you give this guy 1, the output would be 1. If the input is -1, and if the input is -1, the output is also going to be -1 as well. So as you all know, if you want to draw this one in this some kind of x-axis and y-axis and on the coordination form, we do have a line like this. The line is going to straight and it has a 45 degrees of angle. And also, if you guys remember, we had 2 important definitions from the previous part or algebra 101. It was about the range and it was about the domain. So range means that whatever values that I can add instead of x. As we know, x is a variable, so right now is unknown, and it's completely dependent on me that I would like to what kind of variable to put there. So at f of x is equals to x, my some kind of choosing point or some kind of my hand is completely free. I can use whatever number that I like from negative infinite to positive infinite. In the meantime, I know my output is going to be as the same as input. So my output is also going to be negative to positive infinite. For the input, I do have this range of numbers that I call it as just the range itself. And after that, for the output, I do have it as domain itself. So let's just talk about it. Talk about the next one, which we call it as quadratic. So quadratic means that I do have some kind of, I'm sorry, by the way, I have to fix this issue because the domain means that whatever number that I can put for my x value, and range means that whatever number that I can get from y value. So my mistake. So another thing that we do have is just named as quadratic. So quadratic means that f of x is x squared. What does that mean? It means that whatever number as x, if you give it to this function or to this machine, is going to find a power of 2. So obviously, whatever number, the power of 2 of the specific number that you consider inside your head would be considered as positive. So it means that at this point, my domain is going to be negative infinite to positive infinite. That is okay because my domain is the x-axis. But my y is going to be from 0 to positive infinite. For instance, at this point, if I would like to draw that one, I give this value or I give this function 0 and the output obviously is 0. I give that one 1 and the output obviously going to be 1. But if I give the input 2, my output is going to be 4. In the same time, if I give my input negative 2, the output will be 4 because we know if we just find the power 2 of every number, it doesn't matter, it's going to be a positive or negative, the output all the time is going to be positive itself. So this is the second parenting function that we call as a quadratic function. At the end, we do have cubic function. Again, it's just so like the quadratic function, but at this point, we do have the power of 3. It means that whatever number that you give to this guy is going to find the power of 3 of that specific number. So as you can see over here, the drawing would be like this, and the domain or the x-axis y's would be negative infinite to positive infinite. At the same time, the y would be negative infinite to positive infinite. So if I give this guy 0, my output would be 0. If I give this guy 1, my output would be 1. And also if I give this guy negative 1, my output would be negative 1. So maybe some of you would ask, how come we do have negative 1? It's simple. Negative 1 times by itself, 1 times negative 1 is going to 1 because negative times negative is positive. And 1 times negative 1 is going to be negative 1. That's why I do have this guy at this point itself. Another part, we do have another kind of parenting function which are not that kind of common, which still we do have them, and you guys have to somehow memorize this, some kind of how you draw them. By memorizing, I'm not saying that try to memorize everything because you're just using some numbers, some x's, and after that finding some y's or f of x, you can easily draw that. But at some point it would be better to memorize them because some of them are a little bit special. Y f of x is equals 1 over x is a little bit special, and it would be better to some kind of have it in your head, and after that while you're at the test or exam or anything related to that, instead of just try to draw it, find some numbers x and f of x, try to draw it just immediately out of your memory itself. So the very first one is f of x is square root of x itself. So what does that mean? It means that at this point, whatever number that I give to my machine or my input, I have to find the square root or radical of that. That's why I call it as square root. So imagine that I give this guy 0, so the output would be 0. Imagine if this guy is 1, the output would be 1. If I give this guy 4, the output would be 2, and I do have this one. So as you can see over here, I don't have anything on the negative side, and that completely makes sense. Why? Because right now, we don't have any number with some kind of under this square root. In the future, we are going to talk about a couple of numbers, which we call it as complex numbers. But right now, we don't have any square root of negative number. That's why your domain is going to x-axis would be from 0 to positive infinite. In the meantime, your y is also going to be 0 to positive infinite. So that was a square root. So let's talk about the reciprocal. What is reciprocal? It means that whatever value that you give as an input to your function, this guy is going to make the reciprocal of that. For instance, if I give this 2, I do have 1 over 2. If I give this 3, I do have 1 over 3, and etc. And the shape would be something like this, and I believe you guys completely understand that why I don't have this specific point. So if you guys remember, I told you that at one point when I do have 1 over x or 1 over whatever variable, I have to find a specific domain for my x. Why? Because my output at some point is not going to be meaningful. For instance, imagine at this point I do have x as 0. What would happen on that time? 1 over 0 is something undefined. Remember, right now we are not talking about positive infinite or negative infinite, but 1 over 0, if you just use the calculator itself, you can see that you got the error. You will have the error itself. So 1 over 0 is undefined. It means that it contains all of the numbers rather than just the 0 itself. And as you can see over this part, as we just talked about the previous part, we do have intervals and it contains all of the numbers rather than just the 0 itself. That's why this point is completely off topic for us. But after that, I can have this positive section and I can have this negative section, and the range also follow the same rule. After that, we do have the absolute value. As we talked in the last module, the absolute value means that the distance of that specific number from your reference, and most of the time we consider reference as 0, right? At this point, absolute value means that whatever value that you put inside this function or machine, this guy is going to convert it to positive. Your x is 2, your y f of x is 2. Your x is negative 2, your y or f of x is going to be positive 2 itself. If we just use the table and after that choose a couple of numbers, you can draw that and you have something like this. It's something like the V shape. So these three alongside with previous three are important ones, and I somehow suggest you guys to memorize them because you're going to need that in the future itself. Another parenting function that you will face a lot in the future is about exponents and logarithmic functions. It means that at this point I do have a specific function which at the first glance could be something just made up, right? But in the future, you would understand it that these two functions are very important and we are going to use it in a lot of advanced science and also in our work itself. The very first one that you have to know is f of x is equals e to the power of x. What is e? E is a specific number that we call it as Euler number, that the number is 2.71 and this number is continuous. But you don't have to remember all of that, and most of the time, as you will tell my students, you just have 2.7. So this, instead of just writing as 2.7, we do have a number as Euler, and x is the power. It means that unlike previous part that x was at the base itself, right now x is in the power. So you can imagine that if I increase the x just by a couple of numbers, my some kind of f of x is going to increase so fast. You also can see it over here, right? So at this point, my x is something negative, and at this point, I do have 0 and 1. Why I do have 0 and 1? If you guys remember, whatever number to the power of 0, it doesn't matter if it's x, it is 2, it is 4, whatever number to the power of 0 is going to be considered as 1. So imagine that my machine is going to receive a 0 as an input. So I do have 2.7 to the power of 0, or Euler number to the power of 0, which is going to be 1. So this is the point. After that, this some kind of everything is going to be a little bit interesting. Why? Because just by increasing a little bit of number of your x, for example, make it as 0.1, 0.2, 1, 2, and 3, you can see that your y is going to increase so fast. So that's why some kind of this function is interesting. On the other side, we do have another one that we call it as ln of x, or logarithmic function. So this logarithmic function is going to do a couple of calculation or do a couple of mathematical thing inside itself in order to find the f of x. Again, this we haven't talked about it before, so right now it is new, or maybe for some of you already understand it, but right now let's just keep it as the way it is. But the important thing about ln of x, or logarithmic function of x, is that ln of x and e to the power of x are inverse to each other. What does that mean? It means that if you draw this line that we know it as f of x is equals to x, or y is equals to x, you can see that if I just move to this kind of distance from this point to my reference, which is y is equals to x, and if I do the same thing, or if I do have the same distance from that point to this point, I'm going to be on the side of a logarithmic function. So it means that these two functions are going to be inverse to each other. So, or somehow we just say that they're going to be mirror of each other, or just some kind of, I do have a mirror, and once some kind of the main guy is going to be considered as exponential function, and that reflection in the mirror is going to be logarithmic function, itself. So right now we just got familiarized with a couple of parenting functions, with a couple of strange function and how we can draw them. But the real and important question is that what would happen if you do have a couple of numbers beside that? So obviously, as you guys remember, y is equals to m of x plus b. So m was the slope, b was some kind of y intersection. So how I can have that? I already know how I can drive y is equals x, but how I can drive y is equals mx plus b or any other kind of function out of that. So this is something that we call as transformations. It means that I have to move some kind of drawing or my function right, left, top to bottom, stretch it or make it expand. Or I have to find the mirror of that one to cross or relate it to some specific reference. Rather than just drawing it by myself, I can have a reference. For example, y is equals x to the power 2. So I can use it and after that move my drawing or function top and bottom or maybe left, right, or whatever values that some kind of question is giving to me. So let's get started. So at this point, I do have y is equals f of x, or it would be better to recall it as this. Y is f of x plus k. What does that mean? It means that I do have my f of x, whatever value it could be, and I do have another number as k. So we call this guy as vertical shift. What is vertical shift? Vertical shift means that my value of f of x should either move top or move to bottom. How I can know it's top or bottom? It's easy. If my k is something positive, I have to move my graph to the top, and if my k is negative, I have to move it to the bottom itself. Imagine that I do have this guy as my main point. I do have it as my main function. Y is equals x to the power 2, right? So how I can find a y x to the power 2 plus 2? It's simple. Instead of just having 0 at my point, should move 2 to the top. Remember, only 2 to the top. There is no left and right, just 2 to the top. So at this point, my reference or some kind of beginning area or the beginning of the domain, the beginning of the range or acceptable y values, instead of just starting from 0, would be started from 2. And that is completely obvious, right? You can just have some examples. For example, if I use x as 0, my y is going to be obviously 0. My y is going to be 2. If I do have x as negative 1, my y is going to be what? It is going to be 3. And if I do have x as 1, again, my y is going to be 3. It means that whatever value that you put for x, not only you have to find the power of 2 of that specific value, but you also have to add it with 2. It means that some kind of reference or your beginning point is going to move up by 2. On the other hand, we do have horizontal shift. It means that rather than just moving something up and down, we also have to move it left and right. So how we can understand that, instead of just having the number or whatever value outside of f of x, is this time we do have the value beside the variable inside the parentheses. So I do have y is f of x minus h. So h again is just like a number like the k itself. So this is so important, please be careful. When you have x minus h, right now we consider h as a positive value. When you have x minus h, it means that you have to move your graph to the right. When you have x plus h, means that you have to move your graph to the left itself. It means that whatever sign that you have beside the h, you have to use the inverse sign. Negative means that you have to move to the right. Positive means that you have to move to the left. Imagine that I do have y is equals x minus 3 to the power 2. It means that I do have a negative value, so negative 3, I have to move to the right. By how many steps? By 3 steps. So I do have something like this. Again, some kind of y hasn't changed, but the only thing that has changed is that my x is going to start from the 3 itself, or you just at this point. So if I would like to have a couple of examples over here, we can just have these guys. Let's just have these examples and let's just make some kind of a new page and talk about it there. Cool. So the very first example, it would be y is equals, or my g of x. By the way, it doesn't matter what kind of name you use for your function. It could be f of x, it could be g of x, it could be anything. F is very common and it's very easy to remember because f is the beginning letter of the word of function. That's why we most of the time use it, but it doesn't necessarily mean that you have to only use that. So g of x is equals to square root of x plus 4. So as you can see over here, I already know about the square root of x How was that? It was something like this. So this is my reference. This is the beginning of the part. After that, I do have plus 4. It means that I have to move this guy to the top by 4. How we can do that? So I have to do something like this. This guy is going to be moved to the top, and I do have it by 4 itself. As simple as that. So as you can see over here, the very first thing that I have to consider is just the main function itself. I would just want to do have a square root of x, and after that I have to move it to y to the top because I do have positive 4 itself. So let's see another example. I do have I do have f. So h of x is absolute of x minus 5. So as you can see over here, I don't have anything beside of that, and I do have everything inside my f of x. So I do have my y is equals, or sorry, h of x is equals to absolute of x. This is something that I know. And after that, I do have a negative sign. We know if we see a negative inside the parentheses or inside our function itself, we have to move to the right. So the only thing that I have to do, I have to move this guy 5 to the right itself, and I do have positive 5, so this one is going to be my answer. And the final one is h of p of x plus 1 to the power 3 subtracted by 2. As you can see over here, I do have 2 of them. Not only I have to some kind of shift it to the top, I also have to shift it to the left or bottom itself. So again, let's look at this. P of x plus 1 to the power 3 minus 2. So as you can see over here, I do have a minus 2. The very first thing that I have to do, first of all, I have to draw the power of 3. So how was that? It was something like this, right? It wasn't something like that because I already myself is forgot how was that guy. Yes, over here. So my bad. So I do have it again. Let me just clean that like this. So it was something like this and something like this. What should I do? I have to do 2 things. The very first thing is that, again, it doesn't matter which one you use at the beginning. You can use this one and after that use this one, or you can use this one and after that. It doesn't matter. So it means that I have to move my guy, which is x to the power 3 as my reference, -2 to the bottom. So it would be something like this, the very first part. Just approximation, I guess. You do have a very bad drawing, but you can do better than me. And after that, I do have x plus 1. As you can see, I do have plus, so I have to move to the left. Whatever value that I have, it should be something like that. It's just approximation. Yep, so you got the concept.